Okay, so we're going to talk about simplifying or converting radicals. We're also going to be talking about how to rationalize your denominators. Okay, so when you have something under a radical sign or a root sign, this can be simplified. So if there's no number here, of course that means 2. It's an implied 2. So let's say we have 50 here. Because of what we went over in the last video, 50 is the same thing as the square root of 25 times the square root of 2, which of course you can simplify. So the square root of 25 is 5. The square root of 50 will simplify to 5 root 2. You can also do it with cube roots. Let's say we have the cube root of 16 here. That's the same thing as the cube root of 8 and the cube root of 2. The cube root of 8 is of course 2. So this becomes 2 cube root 2, okay? You can obviously go as many roots up as you need to go. However, you're not going to usually deal with anything like that too much. And if that's the case, you could just convert this to, let's say you have a 5 root of, I don't know, x to the 7th. If I were you and you saw that on the SAT or the ACT, I would just convert it to 7 over 5. That's probably what they're trying to do. But this just takes a little bit of not creativity, but insight to work out what to do. If you're trying to simplify the square root of something, look for a factor that is a perfect square. You're trying to find the cube root of something, look for a factor of this number that is a perfect cube. They will also, the right mouse button, I'm just learning to use this new board. You're also going to have to rationalize your denominator. It's a weird skill because it's not that important that we do this anymore. However, high school does expect you to do it still. It was more important when we had, like for trigonometry, you had charts, and sometimes in statistics you have charts and stuff like that. Logarithms would consult these charts. If you look at old textbook, you go to the back and they've got all these charts. And that was a way to help with that, but with calculators, everyone has calculators now, it's not that big of a deal. However, the SAT and the ACT both expect you to do this. Let's talk about the tangent of 30 degrees. Okay, if you don't know what the tangent trigonometry ratio is, go watch the trig video, but we're going to talk about the tangent of 30 degrees. Okay, so the 30, 60, 90 triangle has ratios as this is one of the ratios of a 30, 60, 90 triangle. Okay, so the tangent is going to be the opposite. The tangent ratio is going to be the opposite side over the adjacent side. So the tangent ratio of 30 degrees will be the opposite side over the adjacent side. So this is going to be 1/2 over the square root of 3 over 2. This reduces to 1 over the square root of 3. There's a square root of 3 ratio between these sides, which we'll go over more in the trig video. Typically, the tangent of 30 degrees is not expressed as 1 over the square root of 3, which is also the square root of 1/3. It's usually expressed differently because they expect you to rationalize your denominator. Okay, so to rationalize your denominator, you're going to multiply this by the square root of 3 over the square root of 3, which is just 1, and this becomes the square root of 3 over 3. Okay, because 1 times the square root of 3 is 3, square root of 3 times the square root of 3 is 3. That should be obvious, but I found a lot of times people don't understand that, or it's not completely intuitive, if you will. They get it later, but sometimes it's just a little bit like, what? Okay, so that is the square root of anything squared is that thing itself, okay? You're also going to be expected to rationalize, to know how to rationalize something with a binomial on the denominator. So let's say we have x plus the square root of 2, okay? Typically on the SAT or ACT, they will ask you for something that is equivalent to this, but they're expecting you to know how to rationalize your denominator. Because the square root of 2 is irrational, we have to rationalize our denominator. You're not going to multiply this by x plus the square root of 2 like you would with this guy. You need to do something different. You're going to multiply this by x minus root 2 over x minus root 2. That's still just one, but you're going to be expected to do this. These two binomials are called binomial conjugates. So a conjugate is a binomial. Binomial conjugates are binomials that have the same terms, but they have different signs. So a term is something you add or subtract, okay? So these are binomial conjugates. And so when you need to rationalize a denominator and you've got a binomial, you're going to use the conjugate, okay? Let's see what happens here. So the numerator becomes x minus root 2. And this is, when you FOIL this out, it becomes the difference of squares. So first, outside is going to be x root 2. Inside is going to be minus x root 2. Those cancel each other out. And then you're going to subtract the square root of 2 squared, which of course is 2. So this becomes x minus root 2, x squared minus 2. You will be expected to do all of these things probably once or twice on the SAT or the ACT. Okay? Okay.